I've been curious about how large language models perform when you run them directly on a phone. No cloud, no server, just the hardware in your hand. To get a sense on how far things have come, I ran tests on two devices, my older Galaxy S22 Ultra and my new Galaxy S26 Ultra. I also threw in a comparison using LM Studio running in a virtual machine on my NAS, which has an Intel Arc Pro B50 GPU installed. Let's get into the results. So what am I using to run LLMs on Android? That would be MNN Chat. This is an Android app that lets you download and run large language models locally on your device. It's built on top of MNN, a neural network inference framework developed by Alibaba. The app supports a range of open source models and handles both text generation and image generation entirely on device, with no internet connection required once a model is downloaded. It also includes a built-in benchmark tool, which I used in the later portion of this video to get standardized performance metrics across different models on both mobile devices I will be testing. For the text generation test, I used the Qwen 3.54b model running through the MMN Chat app. One thing to note, this model only ran on the CPU. MNN Chat does have an OpenCL option, but enabling it with Qwen 3.5 caused the app to become unstable, so I kept it in CPU-only mode. The other models can run using OpenCL acceleration, but I really wanted to try out the latest Qwen models as I've heard good things about them. I also ran all prompts in non-thinking mode. Thinking mode is more accurate, but I found that sometimes the model would get into an infinite thinking loop and never finish, so I kept it off for consistency. I ran 5 prompts across both phones and tracked 2 metrics: prefill speed, which is how fast the model processes the input, and decode speed, which is how fast it generates the output. Both are measured in tokens per second. Now let's get on with the results of the prompts. The first prompt is, what is the speed of light in a vacuum? On the S26 Ultra, prefill was 68 tokens per second and decode was 14 tokens per second. And on the S22 Ultra, prefill was at 40 tokens per second and decode was at 8 tokens per second. The second prompt was, list exactly 5 fruits, do not use commas, each fruit must start with a vowel. On the S26 Ultra, prefill was at 44 tokens per second, decode at 14 tokens per second. And on the S22 Ultra, prefill was at 14 tokens per second and decode was at 7 tokens per second. The third prompt was translate good morning into 3 languages and format it as a table. On the S26 Ultra, prefill was at 111 tokens per second and decode was at 17 tokens per second. And on the S22 Ultra, prefill was at 14 tokens per second and decode was at 6 tokens per second. Prompt 4 was invent a new holiday and explain how it's celebrated. On the S26 Ultra, prefill was 47 tokens per second and decode was 13 tokens per second. On the S22 Ultra, prefill was 13 tokens per second and decode was 6 tokens per second. And the final prompt was, what's wrong with this code? And I provided a short Python algorithm. On the S26 Ultra, prefill was at 48 tokens per second and decode was at 12 tokens per second. And on the S22 Ultra, prefill was at 13 tokens per second and decode was at 6 tokens per second. On average, the S26 Ultra was about 295% faster on prefill and about 111% faster on decode compared to the S22 Ultra. That's a substantial improvement. Now let's get on to image generation test. For this, I used Stable Diffusion 1.5, which was the latest version of Stable Diffusion available for MNN Chat. Unlike the text model, this one did support OpenCL acceleration, so I enabled it, meaning the GPU was doing the work here instead of the CPU. I ran 5 prompts on both phones and measured how long each took to generate. The first prompt was a close-up of hands tying a leather boot. On the S26, it took 100 seconds, and on the S22 Ultra, it took 353 seconds. The second prompt was a neon sign reading neon dreams reflected in a rain puddle. On the S26, it took 60 seconds, and on the S22 Ultra, it took 168 seconds. The third prompt was a split screen of an astronaut on a red planet and a knight in a forest. On the S26 Ultra, it took 66 seconds, and on the S22 Ultra, it took 206 seconds. Prompt 4 was a desk calendar showing February 29th, 2023, next to a clock pointing at 13. On the S26 Ultra, it took 66 seconds, and on the S22 Ultra, it took 210 seconds. And the final image prompt was an extreme macro of an elderly fisherman's face, documentary style. On the S26 Ultra, it took 59 seconds, and on the S22 Ultra, it took 209 seconds. So on average, the S26 Ultra generated images about 69% faster than the S22 Ultra. That's a real-world difference between roughly 1 minute and 3.5 minutes per image. MNN Chat has a built-in benchmarking tool, so I used it to test a few additional models beyond just Qwen 3.5. Other models I tested were Hunyuan 4B and DeepSeek R17B. It's worth noting that Hunyuan and DeepSeek both supported OpenCL acceleration, while Qwen 3.5 was CPU only. For Qwen 3.5 4B, the benchmark results are, on the S26, prefill was at 44.1 tokens per second, decode was at 13.1 tokens per second, and the time it took to execute was 33.3 seconds. On the S22 Ultra, prefill was 21.2 tokens per second, decode was 6.5 tokens per second, and the time was around 1.3 minutes. For Hunyuan 4B, the results are, on the S26 Ultra, prefill was 151.7 tokens per second, decode was 223.2 tokens per second, and the time was 15.6 seconds. On the S22 Ultra, prefill was 14 tokens per second, and decode was 4.1 tokens per second, and the time was around 2.1 minutes. And for DeepSeek R17B, these are the results. The S26 prefill was 268.1 tokens per second, decode was 12.5 tokens per second, and the time was 32.3 seconds. On the S22 Ultra, prefill was 47.5 tokens per second, decode was 4.4 tokens per second, and the time was around 1.6 minutes. On average, the speed increase on the Galaxy S26 Ultra over the S22 Ultra was 254% increase for the prefill, a 403% increase for the decode, and a 67% speed up in total time. Just for reference, I also ran the same 5 prompts in LM Studio inside of a virtual machine on my NAS. The NAS is running an Intel Core i3 13100 with 64 gigabytes of RAM, of which I assigned 4 threads and 47 gigabytes to the VM. And for the GPU, there is an Intel Arc Pro B50 with 16 gigabytes of VRAM that's passed through to the VM for hardware acceleration. And I enabled Vulkan acceleration in LM Studio. The results came in around 21 to 22 tokens per second across all 5 prompts. One thing to note is that as far as I know, LM Studio only reports a single tokens per second figure. MNN Chat separates these results into prefill and decode, so a direct comparison is difficult. I'm including the numbers here just as a curiosity, but I wouldn't read too much into a side-by-side comparison with the phone results. As for practical use, I describe this more as a curiosity than something you'd actually want to rely on day to day. Running these models puts a significant load on your phone's processor, so battery drain and heat are a real concern. I've had several overheating warnings that will shut down the application. That said, the gap between the S22 and S26 Ultra phones shows how quickly on-device AI performance is improving. If that trajectory continues and battery usage improves, it's not hard to imagine a future where a fully capable local AI assistant running on your phone is actually practical. Programs like MNN Chat are worth paying attention to, even if they are not ready for everyday use yet. Anyway, I hope you enjoyed this video. If you did, please give it a like, and if you want to see more content like this, hit the subscribe button and its bell icon so you don't miss any future videos. Thanks for watching, and I'll speak to you next time.